Hi, and welcome to my room. My name is HAMZA JAMSHAID, and today I'll be giving you a presentation on my project, which is my IBM Advanced Data Science Capstone project, and the topic is human activity recognition using the data that has been collected from the gyroscope and the accelerometer in a smartphone. Hello, and welcome to our presentation on the IBM Advanced Data Science Capstone project. Our project title is Human Activity Recognition. In this presentation, we'll discuss the dataset, our use case, we'll explore the dataset, we'll also define our model, we'll select the most optimal model, we'll also apply a deep learning solution, and finally we'll evaluate our model. Our dataset has been published by the Smart Labs of Genoa University, Italy. It contains 10,000 rows and more than 500 attributes. It has 6 different classes which are walking, walking upstairs, walking downstairs, sitting, standing, and laying, which have been encoded as integers from 1 to 6. Our use case is to build a mobile phone application using our trained model. This application would record the user activities, classify the activities, and display the activity-based graph to the user. Here is a list of algorithms that we have used in our models. From the scikit library, we have used a nearest neighbor algorithm, state vector machine learning algorithm, an extra tree classifier, random forest, bagging, and gradient boosted. For our deep learning algorithm, we have built a sequential single hidden layer network. Now let's explore our data. Our data features have been derived from the three-dimensional signals of the accelerometer and the gyro. These signals have been heavily preprocessed for deriving these 561 features, which include applying a first Fourier transform to these signals. Here is a histogram of our activity based on the classes. For example, the most data we have is for the laying activity, which is almost 1400 rows of data. Our next graph is very important, which is a variance graph. This graph helps us to explore our features and how they vary. We have also used this graph to apply our principal component analysis. We can easily see that if we select more than 200 features, we achieve a variance of 98% or more. Here is a definition of our model. First, we'd apply standard scaling or standard normalization to our data. Then we'd apply a principal component analysis. Then we'll train our model and finally evaluate our model. Here is a list of our results. From this list we see that the worst performing algorithm was the Gaussian algorithm and the best performing was extra tree, gradient boosted, and state vector machine. If we pick the best performing algorithm, we see that it has an accuracy of 94%, but our benchmark is 95%. So we improve this by applying principal component analysis to the data. Now we evaluate our state vector machine using a precision and recall. Our most important metric is precision, since we actually want to differentiate between the true positives and the false positives, also the true negatives and the false negatives. We display the precision for all these different classes, also the F1 score for all these different classes. This helps us improve and work on a single class if it is misclassified or if it is the worst performing class. Like here we see that the class number 5 or labeled 5 has the lowest precision, which means that either we do not have sufficient data for this class or our model is not is not optimal for this class. For deep learning, we have created a very simple model. We have applied 3 layers with a single hidden layer. Our activation is softmax, and for loss we have used a mean squared error, and our optimizer is an Adam optimizer. Our evaluation metric would be accuracy. If we print a summary of the network, we see that we have a total of 162,000 parameters. All of them are trainable parameters. Now we train this network for 50 epochs. After training, we apply the model to our test data, and we see that the accuracy is 95%, which is the same as our support vector machine. As a conclusion, we have successfully achieved 95% accuracy using both conventional and deep learning algorithms. For deployment, we make a smartphone application. We are also looking to enhance our model by collecting more data and improve the accuracy up to 95%. You can also contribute to our project via public GitHub repository. The link is given below. If you want to work on the human activity recognition, or you're looking to improve your own model of human activity recognition, here is a list of websites that you could use. So okay guys, that was it for my presentation. Now if you guys could help me out in improving my model, I'd really appreciate it. You guys can mention it in the YouTube video, and thank you for your attention again, and have a good day.